All right, let's dive right into this explainer. Today, we're looking at a cosmic weather forecast so impossible, it's had astronomers completely baffled. I mean, for decades, we've looked up at the stars and imagined extreme temperatures and wild storms, sure. But honestly, nothing quite prepared us for a planet with a daily weather cycle so violent and so alien that it basically challenges our entire understanding of planetary science. Just think about this for a second. What if you woke up, looked outside, and your morning fog wasn't water, but vaporized rock? Literally, a sky choked with thick, heavy mineral clouds floating right above you. But then, by the time evening rolls around, that impenetrable rocky fog just vanishes. It burns off completely, leaving behind a scorching, crystal clear sky. It sounds totally like science fiction, right? Well, as we're about to see, it's actually completely real. We are talking about the newly analyzed exoplanet, WASP-94a b. It's the primary suspect in this massive astronomical mystery we've been trying to unravel for years. Located way out in the constellation Microscopium, this gas giant is basically our perfect natural laboratory right now. It's showing us exactly how planetary atmospheres behave under literally the most extreme conditions you can imagine. So, this bizarre world sits nearly 700 light years away from Earth. And, peering into the atmosphere of something 700 light years away, historically, it's been incredibly frustrating. We knew there was a massive planet out there, and we knew it was covered in clouds, but those clouds acted like a giant, impenetrable brick wall, just totally blocking our view of what the planet was actually made of beneath all that fluff. So let's get into the hot Jupiter mystery and how we're finally peering through this alien fog. To understand why this weather is so intense, we gotta look at what kind of world this actually is. WASP-94ab is what we call a hot Jupiter. Basically, these are massive gas giants, kind of like our own Jupiter, but they orbit incredibly close to their host stars. To put that in perspective, WASP-94ab orbits its star even closer than Mercury orbits our sun. Because it's practically hugging its star, it's just constantly getting blasted by intense heat and radiation. And this perfectly captures the headache astronomers have dealt with for decades. David Singh from Johns Hopkins University nailed it when he said observing these hot Jupiters was like trying to look at the planet through a foggy window. Older instruments, even the legendary Hubble Space Telescope, just didn't have the chops to separate different parts of the planet. They essentially took the cloudy data and the clear atmospheric data and just squished them all together into one big, blurry average. It made it practically impossible to figure out the true dynamic weather going on. Moving on to the investigation, where JWST cracks the case. So how exactly do you solve a mystery when your main piece of evidence is 700 light years away and totally covered in fog? Well, you bring in the biggest, most advanced tool humanity has ever built, the James Webb Space Telescope. JWST finally gave researchers the power to localize their observations, and the way they did it is just fascinating. By watching the planet transit, or basically cross right in front of its star, the team used JWST to isolate the starlight filtering through the planet's atmosphere. The absolute game changer here was that they could actually separate the light hitting the leading edge of the planet from the light on the trailing edge. Now, you might be wondering, why does that even matter? Well, on a planet this close to its star, the atmospheric winds are absolutely massive. We're talking winds that carry air from the cooler night side straight into the searingly hot day side. Because of how this works, the leading edge of the planet during transit is actually its morning side, and the trailing edge is its evening side. So for the first time ever, scientists weren't just getting a blurry global average, they were getting a highly localized morning and evening weather report.
Which brings us to the reveal. A literal tale of two skies.
What the JWST data showed was an unbelievable daily weather cycle that we had never directly observed like this before. The dichotomy here is wild. Think about the morning side. It is just packed with thick clouds. But remember, these aren't fluffy water clouds like we have here on Earth. These are made of magnesium silicate. It's literal rock fog. But then consider the evening side. It's completely crystal clear, with temperatures soaring past a blistering 1,000 degrees Fahrenheit. So how on Earth, or well, how on WASP-94a b, does a cloud made of rock just vanish? The researchers actually proposed two pretty extreme scenarios. Think about how morning dew burns off on Earth. It might be kind of like that, where these heavy mineral clouds get dragged super deep into the planet's atmosphere by those powerful thermal winds, completely hiding them from our view.
Or, and I think this is truly mind-bending, as the clouds move toward the blazing day side, the insane 1,000 plus degree heat literally just vaporizes the rocks entirely.
But wait, here comes the plot twist: correcting cosmic chemistry. Discovering rock clouds is obviously incredible on its own, but the disappearance of those clouds actually solved an even bigger, older mystery. Because that evening side was suddenly clear of the fog, scientists finally got a clean look at the planet's true atmosphere. See, older data had suggested this planet had bizarrely high levels of carbon and oxygen, like so high it was breaking all our planetary formation models. But get this, JWST definitively proved that the old data was just skewed by the clouds. The actual chemistry of WASP-94ab, it only has about 5 times more oxygen and carbon than our Jupiter. It turns out, once you strip away the vaporized rock, it's actually a very familiar Jupiter-like world underneath. This naturally leads us to a new planetary era, looking far beyond the fog. Let's talk about how this kicks off an entirely new era of exoplanet meteorology. Because this isn't just some isolated, one-off freak incident. It's the beginning of a completely new way to understand the galaxy. Researchers have already taken this exact JWST methodology and found similar superactive cloud cycling on 2 other hot Jupiters, WASP-17b and WASP-39b. That pretty much proves these highly dynamic, localized skies are surprisingly common out there. And right now, astronomers are expanding the search to even weirder planets, like gas giants on highly eccentric orbits that basically slingshot through their star's habitable zones. The bottom line is, we're no longer just staring at blurry dots of light. We're tracking the daily weather and the atmospheric chemistry of worlds hundreds of light years away from us. As we finally clear away the cosmic fog and get our first unhindered looks at these alien atmospheres, we really have to ask ourselves, if a planet where rock clouds vanish every single night is just the beginning, what other mind-bending, impossible mysteries are waiting for us in the alien skies right above?